Hello, welcome everyone to the Argo Flux Dev meeting. It's the 31st of March, and it looks like we don't have anyone who's new today. And we don't have actions from last time.
I can give a quick update on some of the things I've been working on. So as I mentioned last time, I am focusing less on the Argo CD and Flux CD stuff and focusing on the AWS service operator. So I've been doing quite a bit of work on a toolkit and a set of command line tools that help to process the AWS service API models from upstream, meaning the AWS SDK Go, and converting them into OpenAPI 3 schemas. And this will be the sort of the foundation for construction of the CRDs that the AWS service operator will use for describing various AWS objects, S3 buckets and SNS topics and SQS queues and that kind of stuff. Anyway, that's kind of what I've been focusing on. My sort of long-term vision is to have very tight integration between the AWS service operator and Flux CD, and just enable infrastructure, cloud infrastructure to be created in the same fashion that Kubernetes native objects are. So.
Can you say a little bit more about what you mean by the tight integration with Flux?
Yeah, so I mean, Flux essentially communicates with Kubernetes, right? To determine the delta between what's actually exists in the Kubernetes cluster and what is desired, right? In the Git repo, in the configuration repo. The AWS service operator will allow Flux, through its communication with the Kubernetes API, to determine what is the actual state of those infrastructure objects, whether those are, like I said, S3 buckets or SNS topics or something like that, and the desired state that'll be represented as CRs in the configuration repo. Right now, and perhaps Michael, you can talk a little bit about how Flux can work with like other tools to manage the infrastructure space, but things like Terraform Plan are kind of analogous here, Cornelia, to how Flux CD would interact with Kubernetes, which would interact with the AWS service operator to return status information about cloud infrastructure objects or resources. I don't know if that makes sense.
That sounds pretty cool. So the idea would be that Flux makes sure that the custom resources are up to date. And since those are up to date, then the resources themselves
So
get
just
created
like just like Flux can query the state of a deployment or a service via the Kubernetes API and determine the delta, right, between what's represented in the Git configuration repo in manifests and what's actually out there in the cluster. It'll be able to do the exact same thing, but in the exact same fashion, just simply by speaking to the Kubernetes API service. But it'll be able to do that for S3 buckets and SQS queues and RDS databases and stuff like that.
Flux leans pretty heavily on Kubernetes' own reconciliation loop, as you know.
Yep.
So I assume that the operator will do some of that as well. Yeah.
Yes,
right.
Precisely.
Yeah, that's
Yeah, go ahead.
That's exactly what I'm poking at here, is that it's the operator, it's the service, the AWS service operator that is responsible for making sure that what has been committed to Kate's into etcd, the instance.
No. So the AWS service operator runs a reconciliation loop for each specific AWS service. So let's take S3, for example. And if an S3 CR has been written to Kubernetes, meaning it's gone through the etcd store, gone through RBAC, got written to the etcd store, and the AWS service controller for S3 receives an event saying, hey, on the shared informer saying, hey, a new CR of type S3 bucket has been created. The way that it works is, if the CR was created with an ARN, that essentially is informing Kubernetes that an existing object in AWS service it already exists, and just to make Kubernetes aware of that. Whereas if the CR is written and does not have an ARN field, that's essentially saying, no, we're expecting that the AWS service operator will create this in the backend AWS service, in this case, an S3 bucket, and make sure it exists. So yes, the AWS service operator will be doing that reconciliation process.
Okay.
But there will be one reconciliation loop, one controller for each service, S3, SNS, etc.
Okay. Okay, so that makes sense. So here's my question, is that Flux is responsible for making sure that what you have in a Git repo, so the CR, whether it has an ARN or it doesn't, it's responsible for making sure that what's in the Git repo has been committed to Kubernetes.
Correct. Way that, go ahead.
So what is it that Flux is doing if it finds out that, let's say, the thing that it committed into Kubernetes isn't running? Flux doesn't play a role in that. It's the AWS service operator that does.
No, so Flux views the Kubernetes API as its source of state truth, right? As far as like what is actually existing, right? So if the configuration repo in commit A does not have an S3 bucket CR, and in commit B it does, then Flux will essentially say, oh, it will communicate with Kubernetes API server and say, oh, well, Kubernetes API server is saying that it doesn't have any record of an S3 bucket with this particular name. And Flux will essentially do a kubectl apply to create that resource. Michael, am I incorrect in that? Or
it's mechanically simpler than that. The kubectl apply does that bit where it says, does one exist? Yes, no. So Flux doesn't try to do that itself. It just lets kubectl apply do that.
Oh, okay.
And if it does exist, then it says, okay, well, I need to patch it then. So there's a bunch of logic in kubectl apply, which is quite difficult to recreate outside of kubectl, which does the thing you were just describing.
Okay.
So it would work the same for AWS resources. If you changed it in Git, then it would get changed. It would get applied and therefore changed in Kubernetes. So the sort of synchronization point is the record of the resource in Kubernetes' database.
Right.
So that, so Flux puts it there or updates it or does whatever, and your operator sort of takes over from there. And that is your kind of from the point of view of your operator, yeah, Kubernetes is a system of record, if you like. And all Flux is doing is extending that out to Git.
Yep.
So then you've got a kind of line drawn between Git and the far side of your operator.
Yep. So again, Flux doesn't play any role in the actual state of what you've asked for. That is entirely up to whatever the operator is, in this case, the AWS service operator.
Right. Although the record of configuration change is stored in Git, and Flux facilitates the rolling forward or backward of that configuration state via Git, right? So
yep.
Yeah, I guess I just wasn't explaining myself correctly there.
I think all the things that you think happen do happen. You just were mixed up about which bit does which.
Gotcha.
Yeah, so in other words, another way of putting it is to say that the controllers that are running in Kubernetes that are actually keeping the actual state of deployments in alignment with what has been asked of Kubernetes, so what's been committed to the Kubernetes API, that is completely opaque to Flux.
Right. I was mistakenly merging the work that kubectl apply does to generate a list of patch operations, or the strategic merge patch. I was mistakenly merging that together with what Flux is doing.
Yep. Okay, so thank you. That long conversation just confirms that my understanding of Flux is correct. I just wanted to make sure that there wasn't some like part of the contract there where I'm like, is Flux really looking at what is actually running on AWS? But it's not. It's only looking at what Kubernetes believes the desired state is.
Right.
Yeah.
Right.
Yeah.
My apologies.
No worries. No worries. I just wanted to make sure there wasn't some like amazing magic happening that I didn't know about.
No, the amazing magic, I guess, is in the kubectl apply logic.
Yep. That makes sense.
All right. Well, that's that's what I've been working on. The initial services that we're aiming to get an MVP out for are S3 for this AWS service operator, which we're actually renaming to AWS controllers for Kubernetes, but whatever. Let's just continue calling it AWS service operator for now. So we're targeting S3, SNS, SQS, I believe RDS, and there's a couple more, but one thing that is not targeted is IAM, just because of the giant security hole that poses. Because if whatever objects that the service controller ends up having to create in AWS, the service controller needs IAM permissions in order to create those things. So if you get a IAM role that's associated with the service controller for IAM that can then create IAM roles itself, that's a pretty giant security hole. So for right now, we are limiting the MVP to not include IAM, meaning that the AWS service operator will not be able to create IAM roles or permission sets itself. The IAM administration will continue to need to be done outside of Kubernetes.
Hey, Jay, are you going to publish the opening API specs?
Yeah, yes. So
Cool.
Here, I'll give you a quick heads up on this thing that I've been struggling through. So here, you're more than welcome to take a look at this project here. So as anyone who's worked with the AWS APIs can tell you, they are all idiosyncratically slightly different and inconsistent in the way that they represent the same things, like tags and stuff like that. Anyway, so trying to get a consistent representation, especially outputting like an open API schema that could be then included into a V1 custom resource definition or extensions Kates.io V1 custom resource definition as a validating schema is difficult. I'm 95% there for the APIs that we're most concerned about here, but I'm going to continue working on them. So the way that the AWS APIs are modeled in upstream uses this system called Coral inside of AWS. Anyway, the way that it's modeled is a little wonky. So, and again, each API is a little bit different. So yeah, it's been fun scraping
Good times.
through API
Sounds
models.
Yeah.
But yeah, you can use this AWS API tool to sort of explore the different API models. And if you go all the way to the bottom of the README, you'll note the OpenAPI 3 schema. So you can specify an API and a resource name, and it'll output the OpenAPI schema for that particular resource. That's the information that is going to be the input for the generator inside the AWS service operator.
Where did you put the link, Jay?
Oh, sorry, in the Argo Flux Dev agenda. I'll here.
Okay, that's cool. No, it's all good.
AWS API tools.
Yeah,
I know where to go look now.
I put it in
Coolsies.
the. Anyway, so yeah, I'll continue working on that Open API schema generation thing and get that in a little bit tighter shape. And like I said, those Open API schemas for the different API resources will be what is used by AWS service operators, generator of generators. You'll love this. It will take these Open API schema documents and generate the types.go files that are then used by controller gen and other generators inside the Kubernetes API machinery to generate a controller. So anyway, lots of lovely meta programming going on here, but yeah, feel free to check it out and provide pull requests and thoughts and feedback and whatever you'd like. The reason I talk about all this AWS service operator stuff is because I truly believe that this declarative management of infrastructure is just as important as declarative management of application state. So for at least the AWS infrastructure side, the AWS service operators, the kind of the glue that will enable us to get to a full declarative management state of both applications and infrastructure using Kubernetes native stuff.
And I would pile onto that, Jay, that it's absolutely that it's important for applications as well as infrastructure, no question. But what we're poking at here is this notion that GitOps is not the same as Git CD. GitOps actually requires you to have the right controllers at the back end to actually do the operational stuff. And we get to true GitOps when we have a reconciler like Flux that is, the Argo Flux, that is doing the synchronization from a Git repo into Kubernetes. But then if you don't have the reconciler at the back end that's actually doing some of the operational stuff, then all you've done is deliver. Mm-hmm. And you don't actually have continuous operations. And so
I agree.
I think that what you're doing here with the AWS service operators, you're saying, here's yet another class of controllers. What we've done at the application tier is we've only been taking advantage of the controllers that are built into core Kubernetes, the replica set, the deployment, and so on. What you're doing here is you're bringing up this, that's why it's so relevant in the context of this conversation and this community meeting, is to say, actually, Flux Plus, you can also bring these other controllers, then you start to get full GitOps.
Yes, and I think probably the most interesting and challenging area is the rollback case. So not necessarily, you get a new Git commit which represents a set of configuration for your target, but if you need to roll that back, you're essentially doing a Git revert and then applying whatever the state of the Git configuration or the manifests were in that particular rolled back Git commit. For some resources, particularly the stateful ones, that can be challenging, right? Because you don't necessarily know what state changes have been made while your the commit that has been rolled back, you don't necessarily know what underlying state changes have been made to those resources, databases and things like that. So anyway, it's going to be interesting as we sort of delve around these more interesting resources like RDS database clusters and things like that, to see how well they respond to automated rollback mechanisms in those reconciliation loops.
So if I could poke on one other thing, and I think this is really relevant to this conversation because the operations controller is just as important as the delivery controller, if not more. Well, at least as important. So in this case where you described the ARN, where you've already created an object and then you're bringing it into Kubernetes.
Right.
If you now make an update in a Git repo, and you say, for example, I need more capacity in my RDS, I mean, maybe that's one of the configuration things. Does the controller actually then start to assume some operational responsibility for that RDS thing that was brought in via ARN?
Yes. So if the, like I said, if the ARN field in the spec was set, that essentially indicates that you're asking Kubernetes to sort of adopt this resource that's been previously created outside of the AWS service operator. The way that we currently have it set up is that the AWS service operator will continue to drive to make whatever that object that is represented by that ARN, that is referenced by that ARN, look exactly like what's in the spec of the CR. And for objects that do not have that ARN in the spec, that means that the user essentially placed the manifest for the CR down and expects that the AWS service operator will end up creating that resource. There is a status ARN field, which indicates that the object essentially has been created in the backend service. So even for those objects that end up being created by the AWS service operator, if someone goes in behind the scenes and changes the desired capacity of that particular object, the next time the reconciliation loop happens, AWS service operator will drive it back to whatever's in the Git configuration repo. Does that make sense?
Okay. Yep.
And again, there's some peculiar resources around IAM that when we started looking into this, we just saw some security holes that we just weren't willing to step into. So there are some resources and services that we just said, yeah, we're gonna continue to require some manual setup on that side. Hey, Mike, how are you? How'd your workflows and events meeting go last week?
I think it went pretty well. I got some good feedback from Bob, and I actually had to adjourn early for a pressing issue internally, but I got good feedback from Bob. Said it was a good crowd and well received.
You mean the TGIK?
That
No,
is,
it was an Argo workflows and events get together. I think
Right.
it was noted in the agenda from a couple weeks ago. It was March 18th.
Ah, okay. It was Argo Events was also featured on TGIK last Friday.
right.
Okay, cool. I think I should start listening to that.
Yeah,
Good.
recording.
Good thing is it's recorded.
Yep.
Yeah, okay, good.
I still have to go back and watch it as well. It's been unprecedented times are making the calendar unprecedentedly busy.
Yeah.
Yeah, the whole COVID stuff is also challenging. So Alex, want to give us a quick update on where the Argo CD 1.5 merge GitOps branch, how that's going?
So I need, I think, a couple more days to basically just merge master into GitOps branch. And I've been doing it for almost 2 days already. And
Okay.
unfortunately, we made so many changes exactly in the same area of code, which is going to be GitOps engine. That's why it's taking time. But as soon as I'm done, I feel like we're going to merge it like literally in the next few days. Yeah. And then
Okay. Hey, that's great news.
yeah. So it was, we were waiting for 1.5 release, which we just completed, like literally, we created branch literally 2 days ago. And as soon as it was created, we started merging changes. Yeah. And then just on a kind of, it extremely, everything is delayed, but there are some good news. So we fixed, not fixed completely, but it improved a lot long existed issues with very big clusters and OpenShift. So that's effectively going to be useful for Flux as well. So an example of such issue is if you use OpenShift and if you have an extremely large cluster, and it seems like OpenShift maybe has slightly different. So basically, Argo users who try to use Argo with OpenShift with the big clusters, they used to see the sync timeouts, and we made some improvements to kind of basically now Argo uses pagination, and it tries not to do too many queries in parallel, and that improves performance. And so basically now we support the bigger clusters.
Nice.
So it's not everything is negative. That's a positive part.
And Argo, I think, yeah, it wasn't last week, the Argo CNCF, or was it 2 weeks ago?
About
Argo incubation for CNCF?
Yeah, it's yet to be announced. I think it's, but it's like 99% done, I would say. So that's a very good news. Yes, I feel like we are in the process of wrapping it up. And we should hear about it, I think next week. And
Awesome.
yeah, and it's kind of, so right now, I mentioned yesterday that we're going to get 2 people. So 2 people actually joined our team, and now I'm mentioning that because it also, consuming a little bit of my time. I need to help them to, ramp up and.
These are folks going to be working on workflows, though, right?
No, 2 people on Argo CD. So
On Argo CD. Okay,
kind
great.
of, team effectively tripled.
Yeah, tripled in size. The army of one, Alex. It's tripled in size. Cool. Well, thanks for that update. Anybody else got anything they'd like to discuss? If not, we'll wrap it up. Mike?
Nothing of extreme merit. I know that we've just, I guess, from the current situation, we're still very much invested. Want to see, we're very excited to hear that the GitOps engine branch is being rebased on the master. That's exciting. I know I had mentioned it last week, Alex. I think the same goes through for Flux. Like, where have we started to kind of list down the requirements of outside of the refactoring of both projects? Where is the convergence of the two being built? Because the GitOps engine is the set of libraries and packages that you use to build your concrete implementation. What is there a repo for Flux, Fargo, whatever it's going to be called? And how can we start aligning and working on some of those items?
So I can answer that. For good or bad, we meaning myself, a few folks from Weaveworks and a few folks from Intuit have had semi-regular meetings to discuss a long-term product vision for Argo Flux. And those meetings have frankly stalled out a bit. I know that Intuit folks have had some timing issues with tax season and all that kind of stuff. So certainly not spreading blame around anywhere. But I think we still frankly need to settle on whether a single product vision is really what is wanted by all parties. And although in England, I thought we'd agreed to that, but I'm not sure that that's necessarily agreed to by all parties still.
Jay, if I can interject, it
Yeah.
actually, I think that the question that you're posing, which is what do we want to do, especially now that we're just about to get this thing into the CNCF, I think that question is posed to this community. Now, this community is teeny tiny.
Yes.
There's 7 of us on the call. But I hear implied in Mike's question that from his perspective, he'd like to see these things come together. I'll be very vocal and say on record that I think that they should come together. And that we should start to present a project plan for that.
Yeah, I mean, I believe that there's ample opportunity for a GitOps focused suite of tools that are well defined and cohesive. I'm just not sure at this point whether all the parties are bought into that, Cornelia.
Yeah.
So in short, Mike, we still need to have some conversations with Saradi, Mukalika, and Pratik. Got it.
Any option to open that meeting up wider? I'd be happy to attend if it makes sense and or fits in the calendar.
Yeah, unfortunately, I think that's above my pay grade.
So I think the short answer there is yes. Let's, and in fact, I see this forum right here as a major one. The whole reason that we're doing this in the CNCF is so that we can make these decisions in the open.
I could not agree more.
And so I would say that, Mike, for next week, I would love, and I'm happy to take that action item, to throw a straw dog out there that says, here's Cornelia's harebrained thoughts, and start to get some feedback on it. Because I think what you're really asking, Mike, is how do we get going on this? And I think that we can start with a blank page, or I'm happy to fill out something that we can completely throw away, but I can share my thoughts on the way that I think that we should start to bring these things together. Happy to do that next week.
Sounds like a start. And yes, to answer your question from before, or the statement, yes, we are invested in seeing tools converge. Obviously, where, given that it makes sense for both the community, this community, and what we discussed prior. And I don't have an army. I've got more of a militia. So we don't have a ton of horsepower yet, but we're still very interested in participating and taking on, real work where it makes sense for, the community and pushing this forward.
We hear you. Your question and point is well made and heard. Hopefully we can settle these remaining foundational issues this week before the next Argo Flux developer meeting.
Got it. Amazing. No, it's great. I mean, even internally, right? There's at every big corporation, right? There's consensus building and getting everybody on the same page so they can march forward. I always tell my guys that we're all going to be more successful collectively than individually, and I think the collection of just high-class engineers at all the companies, right? The Flux team and the Argo CD team, that is a lot of horsepower behind one project. I think the sky would literally be the limit. No cliche or embellishing that a bit.
Yep, the opportunity is huge.
Yep. All right, so Alex, one thing on yours, we have a big OpenShift cluster, so I'm going to go test that with our big OpenShift cluster because that's been a bit of a pain point for our dev and lab environment, which is the OpenShift cluster. So I will provide any feedback or issues through Argo CD if we run into any with the latest support of big cluster deployment.
That would be super useful, yeah, because these issues are kind of.
Is there something particular about OpenShift? I mean, just does it have a large number of objects or something that?
To be honest, it's my suspicion, but I feel like OpenShift has some kind of proxy in front of normal API Kubernetes server, and the reason I think so is that it feels like proxy just times out waiting for response from Kubernetes API server, and it returns literally text saying, hey, timeout. And then Kubernetes client fails because it expects JSON. And it just...
Oh, really?
It manifests as basically it's saying, hey, I could not deserialize that, that string as a JSON because it starts from T, but it should not.
Yeah,
I think it's HA proxy.
When I first heard you talk about this, I was thinking it was, well, a lot of customers tend to have really big clusters with OpenShift. That's what has been my experience in the past. So I was equating it to the size of the cluster, just the sheer number of nodes and those things. You're saying that it's not actually the size of the cluster, it's something about
some sort of proxy layer that's timing out?
I mean, I would not blame proxy. I feel like proxy is doing the right thing. It just, Argo, I feel like it was basically trying to do not typical thing. It's trying to do a lot of queries at the same time without pagination. And it's like, this is something you should not be doing. And then that causes issues. So it just too many queries and maybe one proxy in front of all of them, and then it just comes out.
Gotcha.
Yeah, so we try to just kind of have a limit on number of such queries, and then each individual query just use pagination to reduce. So it would be lots of frequent calls instead of one giant call. We have several users, and now I'm waiting for for response from them, basically confirmation of testing.
Cool.
I think one of the things we've run into is the pods per namespace. Let's say
Pods per node or pods per namespace?
I think it's pods per namespace. Or per node, pardon me, per node. I want to say that Kubernetes recommends 100. I think if I last checked, OpenShift's recommendation was no more than 200. So there could just be more things going on. And I don't know what ours is at. I could go look at our Grafana dashboard, see what the quota cap is per node. but I know we reduced it down from whatever the suggested was based on the Docker daemon going into a bad state for a couple of our more active and elastic environments.
Yeah, ours, well, EKS and if you use the EKS optimized AMI, the kubelet max pods is set dynamically based on the instance type. And a lot of that has to do with the number of IP addresses that can be assigned based on the instance type is different, right? So.
Yep.
All right, folks.
Cool.
I think
Excellent.
we'll wrap up a little early. Give you 15 minutes back.
Thanks a lot,
All right.
everyone.
Thank you, everyone.
All right, thanks.
See you.
See you in a couple weeks.